Good morning. 3D scanners have been holding an annual PolyWorks conference for the past 10 years, and they have got bigger and better every year. During these conferences, we have showcased Innovmetric's new developments, and many of you have attended these events, and we thank you all for attending our virtual live event this year. I'm sure you'll find both presentations informative, and you'll love the new features added into PolyWorks 2020. We'd have loved to have met you all personally this year, but it's especially exciting because this conference's message is in line with the changes the whole world is seeing. As the world is going digital, all of us, by choice or not, are adapting to digital tools in our lives. The buzzword of today is going to be digital transformation. Every day we enjoy the benefits of digital transformation in our private lives, in our social lives, in the way we consume, and even in our love lives. Digital transformation also applies to manufacturing organisations. For companies such as yours, it's about remaining competitive, fostering innovation, and maximising profitability. Digital enterprises manage their key data globally and implement digital processes. They provide employees with a digital framework that defines, streamlines and supports all processes. Manage the flow of information to facilitate teamwork and communications. And enforce traceability, which is essential to improve the quality of their products and services. We understand that digital transformation is a long-term process. With so many processes, departments and people involved, it represents a significant challenge. We are convinced that the next big gains will come from the company-wide sharing of 3D measurement data and results. Today, we are announcing that Innovmetric are making it their mission to support the digital transformation of your 3D measurement processes. During the first 25 years of their business journey, they've pioneered point cloud-based inspection, invented the concept of universal 3D metrology software platform, and introduced the most user-friendly CMM sequencing workflow ever designed. They are now massively investing in creating the next generation digital data and process management technologies. They want to bring 3D measurement at the heart of your enterprise engineering processes. Innovmetric's success to date has set the groundwork for this new mission. Since their inception in 1994, they have sold 30,000 PolyWorks licenses to 15,000 customers in 95 countries, and 97 of the world's 100 biggest manufacturers use PolyWorks. We are very proud of the success of their enterprise platform. In our business culture, we understand the importance of their solutions to support your company's processes and achieve your business objectives. Delivering the highest quality of products and services is Innovmetric's main focus every day, and with that comes great responsibilities. Relevance is key to ensure that PolyWorks remains a valuable asset to your organisation. They exploit new and emerging technologies that can benefit the user community. They keep optimising the performance and usability of their solutions and interconnect their solutions with your existing digital solutions. Because you can't be successful with technology alone, we have a partnership responsibility. We must be there to accompany your business along its evolution. And we will keep on building a strong team of knowledgeable and friendly people to train, support and advise your teams. To maintain your trust in our PolyWorks solutions for critical enterprise processes, we have a sustainability responsibility. It is of paramount importance that the PolyWorks solutions be well developed and supported in 5 or 10 years from now. Did you know that a few months ago in January, Innovmetric celebrated the 20th anniversary of PolyWorks Inspector? And while revisiting the evolution of their flagship product since the year 2000, they realised that industrial 3D metrology has undergone an extraordinary progression on both hardware and the software sides. On the hardware side, we've witnessed a giant leap forward in the capabilities of 3D measurement technologies. For example, with their flexibility, speed and ease of use, laser scanning arms and handheld scanners have become standard 3D measurement devices in all product engineering departments. Robot-based automated 3D measurement stations have grown in popularity because structured light, laser radar and laser scanning systems offer outstanding global accuracies. and the emergence of quick and accurate laser tracker-based scanning technologies and time-of-flight spherical scanners has made it possible to efficiently digitise large structures. And computing capabilities have increased exponentially, 50 times more RAM memory, which allows us to process large point clouds and CAD models, 8 times more CPUs that we use to parallelise time-consuming algorithms, and 30 times faster processing of 3D display that we use to display detailed real-time graphics while measuring. 3D metrology software has also immensely progressed since the year 2000. In terms of universality, PolyWorks today interfaces with all 3D measurement devices thanks to a universal digitizing hub, performs all inspection tasks using a universal 3D metrology workflow, and deploys universal inspection projects playable on any 3D measurement device. Modern 3D metrology software offer flexible solutions. Their editable parametric operations and automatic update technologies forgive user mistakes. With scripting capabilities and customizable properties, they easily adapt to specific workflows and inspection setups. Leading 3D metrology software solutions offer the tools to automate processes such as an inspection sequence editor to create and edit the automated measurement sequence, an offline simulation mode to build an automated sequence without the need for physical 3D measurement hardware, and software development kits to communicate with external modules or add new functionalities. These major innovations in hardware and software have fueled a major growth in the use of 3D measurement technologies in manufacturing organisations. They are used for product design, prototyping, tooling and production monitoring. But this phenomenal rise in the use of 3D measurement has led to significant data management complexities. When our leading edge customers asked us in Innovmetric to help them optimise their 3D measurement processes, it led us to analyse their data flows and human interactions. The most notable pain points were the difficulties of accessing 3D measurement data files. For example, users reported that measurement files were often hidden on local hard drives. They did not have access to a search engine, and several manual operations were required to share data with a colleague. Moreover, they told us about performance issues with large file transfers taking up all the network bandwidth, and lengthy downloads or uploads of large multi-piece inspection projects. The lack of robustness arising from manually enforced naming conventions. It's so easy to give an incorrect name to a file, place it in the wrong folder, or overwrite an existing file by mistake. And the difficulties of collaborating on 3D inspection projects that lead them to still prefer 2D PDF reports. Solving those productivity and process pain points required adding new technological capabilities to PolyWorks' solution, and it led Innovmetric to develop a bold new enterprise solution to maximise the value of 3D measurement data for our customers' engineering and manufacturing processes. It provides a complete data management solution that centralises file storage and backup and allows enterprise-wide sharing of 3D measurement data and results. We strongly believe that Innovmetric's new digital ecosystem will have a major impact on the efficiency of your engineering and manufacturing processes, and we are confident that it represents a great value. And all the leading edge customers who tested Innovmetric's enterprise solution in 2019 have purchased it at the end of their test beds. Let me tell you what some of these early adopters have said after a few months of use. I have data at my fingertips to answer any question. No worries about whether or not I have enough hard drive space. No downloading, decompressing, opening, browsing for data. Just search, click, and done. Thank you for making our lives a lot easier with metrology and communicating our measurement results. Meaningful measurement data made accessible for any skill level across the company. And we have the ability to data mine inspection data and make conclusions we were never able to make before. It seems once you have moved to the new PolyWorks digital ecosystem, there is no going back. Need more convincing? Several of the enterprise solution users have reported having already saved a significant amount of money after just a few months. And can you guess what aspect of the solution was key to producing those savings? The ease of accessing their complete 3D measurement data. It allowed manufacturing issues to be revealed as soon as they occurred and facilitated collaborative investigations that required accessing the complete inspection projects. With the PolyWorks Enterprise solution, all users store their 3D measurement data in a centralized system. The data is accessible to all as decided by their permission levels, and data is searchable and can be reviewed through a standard web interface. The PolyWorks Enterprise solution is a game changer. It provides access to all your 3D measurement data under all circumstances. Of course, the data managed by PolyWorks is not ours or Innovmetric's, but yours, and we believe strongly in open solutions. Consequently, Innovmetric will provide a software development kit that directly connects to their data management system, to your internal tools and third-party solutions. This business orientation represents a new responsibility for us, as PolyWorks will come to play a more central role in your 3D measurement operations. To respond to this challenge, Innovmetric are planning to enhance the quality and depth of their products and services. They've set up an outstanding software development process that allows them to release software monthly and develop hot fixes within days. This includes automated processes such as continuous integration, nightly executions of tens of thousands of functional tests, and extensive code coverage analysis. Even though they already have a strong foundation in place, they'll keep improving their software development processes. Their enterprise solution requires them to quickly solve any urgent software issue you bring to our attention. To support PolyWorks' metrology suite, Innovmetric and its partners have already deployed 150 application specialists worldwide that speak 20 languages. You locally at 3D Scanners have access to 11 application specialists. This is an excellent start, but to support the deployment of the new digital ecosystem, they will keep on elevating their technical support capabilities to the next level by hiring more specialists, adding information technology expertise, offering extended support hours, broadening communication channels, and adding self-learning material to our dedicated support website. If you didn't already know, we at 3D Scanners have been generating video content on YouTube to help support and guide our customers. We will also offer new courses such as courses on macro scripting or enterprise processes. We'll keep on supporting your needs for customization and consulting services by staffing our teams adequately to manage more customer projects. And we'll broaden our integration services to train, coach and support your teams on site, map and optimize your processes, and configure the universal platform for your 3D measurement devices. We're strongly convinced that our new enterprise solution offers the most significant innovations in the 20-year history of PolyWorks Inspector, and we think that the PolyWorks conferences are a great vehicle to bring the solution alive by presenting real processes achieved by multiple teams, highlighting the innovative data flows and effective human interactions. We also understand the importance of PolyWorks Inspector in your daily work, so be sure that the latest enhancements of PolyWorks 2020 will be featured within our demonstrated processes. Let me conclude this keynote speech with the three most important impacts that the digital transformation enabled by PolyWorks will have on your organisation and your work life. Firstly, the PolyWorks Enterprise solution directly contributes to the enhancement of your company's competitiveness, regardless of its size, by reducing its operational costs and enabling more collaborative processes. Secondly, the PolyWorks Enterprise solution increases the value of your work. It makes 3D measurement data more valuable for your enterprise by giving access to 3D measurement to all stakeholders. And it increases the value of your enterprise within your organisation. We've seen so many great PolyWorks users become prestigious 3D measurement experts within their company. Our enterprise solution will accelerate this trend. And finally, we're convinced that well-balanced digital tools and processes simplify your life at work because they naturally extend your thought process. So, we will keep on designing tools and processes that work for you and increase your satisfaction at work. We're living in exciting times. Together, let's transform your 3D digital measurement processes and bring 3D metrology to the next level, to the digital level. The next presentation this morning is entitled Efficiently Bring Your Final Designs to Production with Keith and Ben. And if you have any questions, please use the questions and answer chat, and you may have to come out of the full screen mode to access that.
Good morning. In this presentation, we're going to present efficient metrology processes that will help you bring your final designs to production. As mentioned earlier in the keynote by Terry, we'll focus on metrology processes enhanced by new PolyWorks 2020 functionalities. The processes we are about to present will combine PolyWorks Inspector, Data Loop, our data management solution, and also Report Loop, our Excel plugin. If we look at the product quality planning timeline, we are at the product and process validation stage. We'll cover important pre-production tasks. During discussions with our users, we have learned that pre-production parts that are produced in-house are quite easy to troubleshoot, as you have complete control over the manufacturing and metrology processes. But the story here is quite different when the parts are produced at a supplier site that is several hundreds of miles away. You look at metrology reports and try to understand the part issues. Are there any manufacturing issues? Hard to tell by looking at a simple PDF report. How about metrology issues? This is a question we would prefer not to have to ask. We expect that a minimum amount of testing has been performed on the measurement system, like a repeatability study or a gauge R&R study. But these studies are sometimes skipped. Why is that? Because they are complex and consuming to run. What if there was an easier way to run a repeatability study using PolyWorks 2020? Another important question to ask in pre-production is the following. Is my manufacturing process under control? Can I constantly produce the parts within specifications? I should have a way to answer these questions without having to export all the measurement data to a third-party SPC software. In the next 30 minutes, we'll answer these questions, putting the new PolyWorks 2020 release in action. During this presentation, we shall cover the following. First, individual parts will be produced and measured by a part supplier until an assembly issue is found. Troubleshooting will be required by the OEM. At the same time, the inspection fixture for a sub-assembly will be assembled and certified for a repeatability study and a gauge R&R study. We'll find worrisome issues with the fixture. At the end, the supplier will prove that his manufacturing process is under control prior to starting the mass production. Some of you told us that it's quite common to produce parts within specification limits and discover problems at the assembly station. We'll see how to efficiently solve these assembly issues. The main challenge in this troubleshooting process is to have an efficient collaboration between the OEM and the supplier to minimise the back and forth discussions required and agree on a solution. In this story, an OEM is sending his final design along with the inspector project to a part supplier. The supplier is responsible for producing a sub-assembly. The OEM prepared the inspection projects for the supplier, so the supplier operators only have to download the pre-prepared inspection project from PolyWorks Data Loop. The operator scanned a few pieces of component A, which is the first component of the sub-assembly. Then he scanned a few pieces of component B as well. Once scanned, the data was uploaded to Data Loop. When came the time to assemble the two parts, an assembly issue was found. Using Inspector, the supplier took the time to create a virtual assembly by aligning the two parts using the welding locating holes. So I'm just going to jump into PolyWorks now. So I have this virtual assembly project here on this laptop, and I'm going to upload it to Data Loop so Keith, who will play the role of the OEM manufacturing engineer, can access it. So I'm just going to turn off these features just quickly, and then I'm going to press upload. And in here, I'm just going to type a message so that Keith will receive this. So in here, I'm going to write interference between part A and part B, and then click upload. And I shall now hand you over to Keith.
Thank you. So I've just received an email from Ben. He wants me to review the rail assembly. He's also added an upload comment to make sure it's make it easy for me to find the project within Data Loop. So if we're going to PolyWorks, open, and let's search for interference. And you can see there we have this one project available. So let's open. It tells me there's a newer version, so let's download that version. The search in Data Loop makes it much quicker than browsing within folders on a file server. There should also be a control view for me to view. Clearance and interference. And clearly there is interference on this virtual assembly. So what I'm going to do is take a look at the components and analyze this edge and its variability to verify if it's a cause for widespread interference or if it's just limited to this one bad piece. So let's search for the component. Search for rail. And rail part B. So look at this project here. There's no need to save. There should also be another control view in here to make it a little bit easier to find the area I'm interested in. I believe it's Ben 3. You can see here we've got a couple of comparison points, but not quite on the edge that we're actually interested in. So what I'm going to have to do is add a few controls to verify this area on all pieces. I believe trim comparison points are probably going to be the best tool for this, so I'll add a couple along this edge. So let's just clear up the view first. Let's jump into my trim as comparison point tool. And I'm going to anchor a couple of extra comparison points on this edge. Just to quickly show you, if I go into my SPC mode, you can see that the annotations turn into little trend charts. You can see that none of the previous pieces have these comparison points in there. So obviously what I need to do now is make this part the same as all the other pieces. But PolyWorks 2020 has a great new tool to allow me to do this. Let's just select all those. So we can propagate changes automatically in PolyWorks. It will do the job of propagating this change to all other pieces for me, and I do not have to do this manually anymore. It'll avoid the possible human error when making changes to multiple pieces, and the job is done much quicker than I could manually. It's a powerful analysis tool since we are leveraging the previously scanned data to get new information in an automated way. We are extracting the full potential of our scan data, and new objects created in one piece can be propagated automatically to the other pieces in the same project. And that should be about done. And then what I can do is I'll turn on the SPC again to quickly show you that this has actually been applied to all the previous pieces. We can see that it's not a single piece that has an issue. All pieces are the limit or outer tolerance along this edge. The actual CP value is good, so the process repeats adequately, but the CPK value is not centered so we are not centered on tolerance. So the supplier's laser trimming should be adjusted to be closer to the nominal, and at the same time, I think we should tighten the tolerance values in the specifications. Now, to quickly communicate this information to the supplier team, I can upload to Dataloop and let everyone see the same results as me within seconds, not hours.
With direct access to the 3D metrology data, the OEM could rapidly identify the problem using the virtual assembly data and send the corrective action to the supplier. The laser cutting will then be adjusted on the supplier side, and tolerances will be tightened on the OEM side as well. The new 2020 Propagate Piece Changes function allowed the OEM engineer to add new metrology data to previously scanned data collected by the supplier to truly understand the problem. Now that the assembly issue is resolved, the supplier can start producing the subassembly. Since this subassembly isn't rigid, an inspection fixture will be fabricated. Then, a measurement system analysis will be performed to determine if the fixture operates as expected. The tooling engineer is creating the control plan on the CAD model of the fixture and providing a complete inspection project to the tooling operator so he can build the fixture.
That's right. I have the fixture fabrication project created by the tooling engineer here, and it contains the fixture datums. It has tooling balls, and it has a sequence that will guide the operator during the contact bolt adjustments. I have uploaded the project to Dataloop for the operator. Using the search in Dataloop, the operator can easily find the project of the fixture. Once the project is opened, the operator can click on New Piece. First, he is guided to probe the initial datum planes. Then, using the Build and Spec tool, the operator is guided for the first measurement of the contact bolts. At which point he can see the required adjustment in height for each contact bolt. The fixture can be adjusted with shims for each contact bolt to get the proper height. And at the end, a final measurement is done. And the project is uploaded to Dataloop.
Hey Keith, hasn't Innovmetric released PolyWorks AR recently? Wouldn't this be a good application for it?
Yes, I think this will be a great application for the PolyWorks AR by using the Microsoft HoloLens. Check this out. Okay, this is a very small fixture, but imagine this process on a large aerospace fixture or a car body framer fixture. It's very interesting to have the results directly on the real part and no need to actually jump back to your computer every time.
Now that we have our fixture precisely built, the next step is to measure parts with it, right? Not exactly. It might be a good idea to verify first if our measurement equipment is repeatable. How are we going to do that? We're going to do a repeatability study. I'm sure many of you already know about repeatability studies, but just to add some context here, the study consists of the operator measuring the same part 10 times using the same measurement equipment. Factors such as the measuring device, the fixture, and even the clamping sequence are taken into account during the study. The goal of the study is simple. We want to measure the equipment variation and make sure it represents at most 20% of the characteristics tolerances. This 20% is a rule of thumb. It can be more or less depending on the applications. This value must be calculated for each key characteristic on the control plan. Another way to express the equipment variation is the gauge capability index. An index above 1.33 means that the gauge is capable of measuring the characteristic. Obtaining repeatable measurements is a challenge. Operators without adequate guidance can introduce variations in the measurement process. Extracting measurements on scan data requires fine-tuning measurement parameters to get the optimal results. Variations will be detected, and you need to understand the source of these variations. Finally, performing the repeatability study itself generally requires exporting the measurement results to a third-party software to finalise the study. Keith, can you show us an overview of how you would perform an efficient repeatability study on this part and using Inspector, Data Loop, and also Report Loop?
Of course. The control plan is used to determine the key characteristic to test during the repeatability study. We have created the inspection project that contains the necessary features, trim edge comparison points, and sequencing. The sequence is built in to the template, and it will be important when we analyze our repeatability study results. We've also created an Excel template for our repeatability study. Once the measurements are complete, we will use Report Loop to analyze our results in this template. And when everything's prepared, we will upload the inspector project to Data Loop. The operator first searches, then downloads the inspector project from Data Loop. Because a nominal project was created, all he needs to do is create a new piece. The sequence begins with the guiding instructions demonstrating the proper mounting and clamping procedure. Then the tooling bores are probed, and the number of points to probe is defined with guidance. Scanning begins, and our operator follows the feature scanning guidance, measuring until the proper coverage is reached for each object. A boundary scan will be used to measure the trim edges and holes, while a surface scan will be used for the constraining planes and other plane features. The scanning guidance reflects this accordingly. The part is removed from the fixture and replaced in between each of our 10 trials to make sure that the process of mounting the part into the fixture is considered as well. And once all 10 pieces are complete, our operator uploads the project back onto Data Loop, so the data becomes accessible for the tooling engineer. So I've got word from the quality team that all 10 measurements are completed and have been uploaded to Data Loop. So I've logged in and downloaded the project. I can see that all 10 pieces are in the project. So now I'm ready for the repeatability study. I'm going to use the Excel spreadsheet provided by PolyWorks to calculate variability. So all I need to do in Excel is connect to PolyWorks. And you can see that the current open piece in Inspector is displayed in bold here. So I'm going to prepare this sheet for specifically the counter sinkhole 1 measurement. So for my features branch, find counter sinkhole 1. I can, for example, insert the nominal value into my sheet, and I can insert my measured value in here as well. And that's going to be our first of 10 trials used for the repeatability study. Now the link is made between Excel and Inspector for this value, I'm going to be able to add the other links automatically. This report loop tool will add all the links in the application in appropriate cells for all the trials in my Inspector project. This spreadsheet calculates the equipment variation as a percentage of the control's overall tolerance. What we want to see is a value of less than 30% of the tolerance used by the equipment variation. It also displays the values from the project on an IMR chart, or individual moving range chart. And that's about done there. So I can see that the equipment variation makes over 400% of my allowed tolerance. I have more equipment variation than my overall tolerance here. I will need to verify the reasons why. On the IMR chart, there is a value that stands out, trial number 6. The normal value is 6.35, and on the measured here, it's more than 9 mil. So I should probably start by investigating that particular piece in Inspector. So if we go back into PolyWorks, jump back into trial piece number 6, and then let's zoom into counter sinkhole 1, and you can see here we have a problem with the hole. I know that this hole is extracted using boundary scan points, and it seems that the cause for this this issue is false boundary points around the scan area due to these holes. I can verify this by showing you the points it's used to measure with. So review, deviations, restore, and you can see there it's using all these points away from the actual hole itself. So what I'll have to do is modify the extraction parameters. So if I right click, go to properties, jump into your measurement tab, and let's reduce the max distance down to 1 mil so it's not searching as far from the hole. And as you can see there, that has fixed the issue there. Okay, now I need to make all these same changes to all the other pieces within PolyWorks. Again, in PolyWorks 2020, Innovmetric introduced a new tool which allows us to propagate piece changes across all pieces. So I connect to that through the bottom right hand corner. I have quick access to the configure propagation, and I'm going to create a new template. I can name it whatever I like, make sure I've got all my pieces selected, and just OK. This new tool in PolyWorks 2020 is a powerful and welcome addition. It makes all the changes for me automatically, eliminating the need to make the same changes manually across multiple pieces. And now the propagation is configured, it can perform it. This was the #1 request from existing customers, from you. It was a great deal of work to make it easy to use and well integrated with both small and large projects in mind. You just saw how easy it was for me to set up, right? What makes this new tool so powerful, not only are new objects propagated, but also parameter changes to existing objects, new control views, and, you'll love this, report modifications. PolyWorks documentation lists all the changes that can be propagated. PolyWorks certainly goes a lot faster than I could manually and makes no errors. This is the first release of their new propagate tool, and their software architects have already started to work on improving the performance of this. So stay tuned to the intimate releases. When the propagation completes, the modification to all pieces become completes the modifications to all pieces, because of the link between the control in inspector and the spreadsheet cell was established when the template was first filled in, the cells can be updated with one click. So if I go back into PolyWorks, so let's go ahead and update the worksheet. So let's see how this affects the result of my repeatability study for that particular control. Again, report loop updates the values for me. Once again, this is no longer manual and error prone. The process is automated and no more exporting and results and copy and pasting values into the cells manually. Human error is removed from this update of all values for all pieces, and much faster than can be done manually. Okay, and that's about done. I can see that my range value is much better using the proper extraction parameters. And reviewing the other results, I am very pleased with the outcome of the repeatability study. We have now less than 30% of the tolerance used up by the equipment variance. The repeatability spreadsheet and the trend charts provide discrete information about part variations on feature locations like features and comparison points. Inspector also offers a tool to illustrate this. It's the Surface Data SPC tool. If I go back into PolyWorks, we can go into our Surface Data SPC tool and let's disable that, initialize. Wait that to initialize. This tool will show the gauge capability values of the whole surface and not only a discrete value at one place. It's like having the entire scanned surface displaying repeatability. This is actually applying lots of comparison points across the surface of the reference model, i.e. the CAD model, and then measuring each of those points against each of the scans. We can see there we have a CG and CG, we can have CG and CGK values, a gauge capability point at any point on the scan. Zoom in there. We can see form variability across all pieces caused not only by the measurement device, but also by the fixture design. We might want to revisit the design of our fixture as the clamping is deforming the part and causing variability issues. And and that would have been hard to see without the help of the Surface Data SPC tool. Not impossible, but this color map makes it stand out and obvious to make my analysis much easier. Uploading the project to Data Loop will make this color map visible for everyone in the web interface as well.
Thanks. In reality, at this point in the process, the supplier would have to modify the fixture design and adjust the clamps and locating pads to get better repeatability. The repeatability issue was crystal clear in the colour map that Keith just presented to us, but let's assume here everything was good. What would be the next step? The next step would be to run a gauge R&R study on the complete measurement system. The complete measurement system is the sum of the fixture, the measuring device, but also the environment and the operator. Let me provide some context here for those of you who are not familiar with gauge R&R studies. The preparation is similar to the repeatability study, except that we use 10 different parts measured 3 different times each by 3 different operators. There are 2 main objectives when running the gauge R&R study. First, we want the equipment variation plus the appraiser variation to be at most 20% of the part tolerances. Second, we also want to make sure our measurement system is capable of measuring the manufacturing process variation. This second goal is really important if you want to use the measurement results for statistical process control.
The supplier conducted the full R&R study and integrated all the results in the updated Excel spreadsheet as he did for the repeatability study. Here are all the results of the preliminary analysis. Operator A produced measured results with a large variability. The deviation range color map for the 3 trials of piece 1 clearly shows the deviation range going up to 4 mil. We have the corresponding results in the R&R range chart. Then if we look at the R&R average chart, we can see that the average deviation values for the operator A are always way off compared to the rest of the results of the 2 operators. One operator's results stand out from the others. In fact, during the study, operator A pointed out that our fixture design wasn't great, as he could see that the part bending when pressing on the fourth clamp. Operator B and C could somehow compensate for this fixture design issue and produce more repeatable results. No need to say that we did not obtain good results in this gauge R&R study. The results are way above the acceptable 20 or 30%, and as you know, this fixture needs to be redesigned.
So let me summarise the process highlights for this complete measurement system analysis story. The powerful feature scanning and probing guidance tools allowed the operator to produce repeatable results. Multi-piece editing was easy with the new propagate piece changes functionality. We could truly understand the source of variation using the SPC colour map. And finally, the updatable Excel spreadsheet. Let's assume now that the supplier had a good fixture design, so he can now measure the first produced sub-assemblies. His measurement system is capable of detecting variations in the manufacturing process. One big question still remains. Are we ready to start the mass production? In other words, is my manufacturing process for both the individual part and the sub-assembly under control? One good way to answer that question is to look at the Process Capability Index. To give a brief explanation of the CPK, I'll use the story of parking a car in a garage. In this image, the car represents the process variation while the garage represents the specification limits. If the car is almost as large as the garage, you'll be able to park, but you'll have to be precisely centered into the garage, otherwise you'll crash. This is the equivalent of a CPK of 1, which means your process is capable, but you better be right on the nominal. If your car is larger than the garage, there are no questions. A CPK smaller than 1 means there is no way you can produce the parts within specifications. And finally, the ideal situation where the car is much smaller than the garage. You can park easily and be a little off-center without any problem. This represents a CPK greater than 1, and this is what you want for producing good parts easily. And now, Keith will show you how you can access this CPK information using PolyWorks 2020.
Of course. All the suppliers measured data are instantly uploaded to Data Loop, so the OEM engineers can search by any part number at any time and have instant access to the latest inspected piece via a web browser. We can review the results, we can review the individual parts if we search for example, the mounting rail. And we'll have a look at, for example, the mounting rail part A. And we can have easy access to all the results of any characteristics. The web viewer also offers an SPC switch, which allows us to review the SPC information of any characteristic on the part as well, even to a point where we can have a look at the problematic edge, as we did before, and we can see now that the parts are now being produced much closer to the nominal. The process capability indices also indicate that the manufacturing process is under control. Same thing if we were to search for the mounting rail subassembly results. We can confirm that the supplier manufacturing process is under control by looking at the capability indices.
So the main highlight here is the instant access to the built-in SPC trend charts and capability indices available to both the OEM and the supplier. No need to output any data to a third-party software. And so, over the last 30 minutes, we have seen that the OEM and its supplier could collaborate efficiently to troubleshoot the interference issue between two parts. Then, we saw an efficient fixture fabrication process, followed by a repeatability study and an R&R study, computed in an updatable Excel sheet. Finally, we just saw how easy it is to look at the built-in SPC results of the first pre-production runs. All these efficient processes were possible using the 2020 release of PolyWorks Inspector, Data Loop, and also Report Loop for Excel. And we will now pause for some questions from anyone in the chat. Like Terry said earlier, you may have to come out of full screen mode to be able to access the chat function. So we'll just wait for that to load up now. No questions?
Okay.
No? Okay, let's just finish off the first presentation then. So in this presentation, you have seen efficient metrology processes for bringing final designs to production. Let me sum up how PolyWorks help make these processes efficient. Firstly, the OEM and the supplier teams were connected through metrology data using data loop. They could share data and troubleshoot issues easily. This is by far the biggest enhancement. Secondly, the metrology specialist had access to a powerful multi-piece editing technology that allowed powerful project setup and analysis workflows, thanks to the new propagate piece changes technology. And finally, metrology specialists had access to updatable Excel spreadsheets linked to inspection projects, thanks to Report Loop for Excel.
Once again, thank you all for joining us today for the first part of our PolyWorks Conference Live 2020 event. We'll just take a brief break to grab a drink or freshen up before we begin our second presentation. 10 minutes time, say 11 o'clock?
Yep.
Okay, thank you.
Thank you. Hello again and welcome back. Just before we start our second presentation, we've received some questions during the interval. What we'll do is we will save those until the end. So if anyone has any questions from the first presentation, please feel free to continue to put them in, and we'll answer all your questions when we get to the end. But for now, we're going to start our second presentation. So just earlier this morning, we presented metrology processes that occur before mass production begins. Now we will show you some other processes that combine PolyWorks Inspector and also PolyWorks Data Loop, our data management solution. In this presentation, we are going to demonstrate enhanced metrology processes during the production stage of manufacturing. So we are going to cover production monitoring, but most importantly, how to troubleshoot production issues using 3D metrology data. Metrology in production environments requires lots of different devices, from the basic caliper or micrometer to high-end automated scanning solutions. How can you work with your wide variety of metrology devices without being affected by different file output or reports? How can you save time and guarantee continuity between pre-production and production inspections? How can you allow users on-site and off to collaborate on the same part inspections? Once you are collecting and consolidating hundreds of thousands of inspections, how can you organise, broadcast and interpret your incoming inspection data and use it to respond rapidly as problems occur? This presentation will address those challenges. Keith and I will show you how to connect all your metrology devices with PolyWorks Inspector and use Data Loop to centralise all of your metrology data. Then we'll present a real example of how to repurpose pre-production inspection projects and adapt them for the production environment. We'll show you how to utilise Data Loop dashboards and 3D metrology data to understand and solve manufacturing issues. But how can we make sense of inspection results from all the devices and software used by a manufacturing plant and its suppliers? When you're working in the production environment, you've got a lot of devices, some using PolyWorks and others connected to any number of other softwares. Inspection data are spread all over in many incompatible formats, making it difficult to share and correlate. Innovmetric has now made that easier for you. As you know, PolyWorks Inspector already natively supports a wide variety of devices through plugins. They are continuing to enhance our device support. And this year, they are introducing the first of a new generation of gauging plugins that opens the door to hundreds of digital gauges. Because, particularly with the wide variety of gauging tools out there, we wanted to make it easier for you to integrate those measurements into your PolyWorks data repository.
That's right. Their first gauging solution uses the MicroRidge mobile collect device. You can now connect nearly any wireless gauge device that you might have. Now, all your gauge stations or your supplier's gauging data can be incorporated directly into PolyWorks' Inspector. The MicroRidge mobile collect system uses a wireless transmitter and receiver wired to the gauge device and the computer. And this allows gathering gauge measurements in PolyWorks Inspector.
But what if you have measurement devices that cannot directly connect to PolyWorks Inspector, such as a particular combination of a CMM and controller, an automated scanning cell, or even an X-ray, or some of the gauges or handheld tools? Using PolyWorks Inspector macro scripts, you can import and centralise your inspection data and benefit from the complete PolyWorks Inspector dimensional analysis and quality control toolset.
Say you've got an automated measurement cell that outputs result files such as XML, DMO, text point clouds, or CSVs to a dedicated file folder on your network. The macro script monitors the incoming files within this folder and imports them into PolyWorks Inspector. Depending on the file content, it may be used to create objects, sequences, and extract measurements in Inspector. So, as long as there is an output from your device, the macro allows you to automatically process your data. This method saves time, reduces duplication, and makes analysis consistent regardless of the inspection source.
All of your metrology data are valuable. The outcome of consolidating your metrology data in Inspector or even in Data Loop is that you can combine these data for analysis. Centralized, unified data collection and storage make your metrology solution universal. Now that you've collected all this data, do you store it locally on your computer? Sure you could, but you've consolidated a large, complete archive of your colleagues' valuable inspection data. There is enormous value in storing it securely together, centralized and easily accessible. The Data Loop core server is a very efficient way to manage your data, giving you and any user with the appropriate credentials quick access to any data you've acquired. Not only does Data Loop allow you to quickly access all inspection data from any device with an internet connection, it also provides useful tools and even non-metrologists can explore the data. To summarise those highlights, PolyWorks is helping you manage your diverse and complicated production environment by connecting to all devices, including digital gauges, making inspection more standardised and universal. And because of this, PolyWorks is able to centralise and securely store all inspection data, not just results together, easily accessible to all users. This is robust measurement data management. But how can you securely and efficiently provide all operators with the inspection projects they need? How can you standardise the inspection platform for production whilst also optimising for each device in use? Your task is to generate and deploy inspection plans for all devices for production. You could create them individually, but you already have an inspection project you created for pre-production. It is way more efficient to just repurpose that project and optimise it for use on any other device. This has a dual benefit. Firstly, you avoid having to make new projects for every inspection device. And secondly, you extend the inspection project life cycles, knowing that with Data Loop, you can control who modifies the project and when.
Yeah, that's right. I mean, let's say I'm a metrology team leader, for example. My task is to create inspection projects, which will later be used by members on my team. Look at this email that I just got from my pre-production guy. He says he's just finished the pre-production certification of a part and he's ready to transfer it to my department, specifically the production department. He'd like to continue inspecting with our gauges, CMMs, and even arms, and take a 1% sample. For continuity, he wants us to keep all the results together in the same project. So I'll just click on this link here and it'll open the Data Loop web interface on the last inspected piece. From the web interface, I can open and view all the other pieces that were measured in pre-production. And because I need to create an inspection template, I'll actually need to open this within PolyWorks Inspector, which I can easily do on the right-hand side here. As we saw, the project contains hundreds of pieces. In the past, I might have worried that a big project like this would have taken forever to download and open. But now, Data Loop has minimal data transfer, which ensures that no matter how large the project is, only the necessary piece data has to be downloaded and opened on my computer. This makes it a lot faster and minimizes data transfer on the company network. See, it's already done now. So both you and IT guys will love it. Now, let's get back to work. There are currently 2 templates within this project, one specifically for the ARM inspections and one for a CNC CMM inspection. The ARM template can be reused directly, no problem at all. However, the CMM will be a bit of a problem since we don't have the same brand and model as our pre-production department. Well, no problem. I will reuse this template and extend the inspection project lifecycle. So if I go ahead and create a new piece template, I can create a new piece template from an existing template, i.e. the CNC CMM pre-production. So we'll call this CNC CMM production. Create. What I'll do here is I'll just make sure that we have the correct device connecting. So in this case, we want to connect using a CNC CMM and just make sure that we have the right device. In this case, we're using our production CMM rather than the pre-production CMM. If I have a look at the sequencing, for example, I can see there's actually an issue within our sequence, specifically to do with this particular tool, which we don't have since we're using a different CMM. Not a problem. If I go to Tools, Adjust the current device, this is the issue in question. So let's change that tool for a similar tool on our CMM, which in this case is the 70 by 2mm probe. Adjust, and you can see everything's updated. Okay, and now this template is ready to be used. Let's continue with the gauging template. I could start this template from any template like I did before, but what I'll do this time is I'll use the ARM-based template. So let's call this gauging. Oops. And let's use the existing ARM-based inspection. We don't need the sequence anymore, so we can close that for the moment. And what I'm going to do here actually is I'm going to quickly just drag and drop the CAD model of the jig. Now, it's not mandatory to have the CAD model to use in this gauge. It's just I'm loading it just to make it easier for us to understand what is going to be measured on the part, and how it interacts with the gauge and so forth. If you didn't already know this, a couple of versions back, you can now actually just simply drag and drop CAD models into PolyWorks, dragging into the 3D scene to load them in, rather than having to manually go into the file file import or the import CAD tool. And as you can see there, that loads in. You can see on the model we have these red pins. These are how the part will align to the jig. And the green and blue areas are actually the locations that we use for the gauge measurements. Now, since the gauge reports a deviation directly and that the part is already aligned to the jig, there's actually no need for any alignments within this project. So I'm actually going to delete those alignments in here. And because of that, I can also go ahead and delete anything relating to the datums. Okay, and all we're doing is measuring a couple of hole features and some surface comparison points. The circles will be inspected using a positional gauge. So what I'm going to do is I'll assign the measurement method for these using the new mobile collect. So jump into the properties, jump into your measurement tab, and we'll change the method to measure using the mobile collect. Apply those changes. And the same thing can be done for the surface comparison points, since they'll be measured using a linear gauge. Either way, the information will be collected through this mobile collect macro. Okay, and that's done. Our gauge template is ready to be uploaded to Data Loop, so everyone else can start using this. So I can simply go to upload. And what I can do is just simply add a simple revision saying that I've added 2 new templates. Okay. Once the upload is finished, any of my team members with appropriate credentials can now view or download the template and start inspecting the pieces. Talking about credentials, how can I make sure that I can control who modifies my templates and who can modify the pieces, delete them, view them, and so on? Well, let me show you what I like, what I would like. I have a Data Loop server that contains some inspection projects. Some of them are made by us, the OEM, and some of them are made by outsourced to suppliers. They both contain piece templates and lots of measured pieces. Let me first introduce my in-house OEM team and the permissions related to the metrology data. Management can only view the results. The metrology team leaders have all rights on all metrology data, and most importantly, they are the only ones who are allowed to edit the inspection templates, which drives how all the pieces are inspected. The metrology operators can then use the templates to measure new pieces or edit existing ones, but only in my in-house projects. Let's have a look now at how the Data Loop server interacts with my supplier working on my outsourced inner hood. My supplier's metrology operators can measure and edit pieces, but only on this specific inner hood project. They can't see or modify anything else in my database. The OEM team leaders in my company have control over the piece templates, which guarantees that the supplier's inspection follows the requirements we specified in the template. Well, how would I set up something like this? Well, as you can probably understand, one new functionality with Data Loop 2020 is that the possibility to control access of PolyWorks projects and pieces. It is done through a web interface and would look something similar to this for my car door project. With this technology, I can easily control who can modify my data and who has access to it.
So what we can see from Keith's demonstration is that it is now easier than ever to combine pre-production and production metrology data. We want to help you integrate all your measurement data and make it faster, much faster, to access massive piece inspection sets while preserving measurement continuity for the life of the part. Innovmetric are also steadily increasing the piece capacity per project, enabling you to look at more complete sample sets, and with the new increased piece capacity of PolyWorks, you may be able to store every single inspection you will ever do on a part in one inspector project, making the part inspection lifecycle more coherent. With data stored in the data loop database, remember that no matter how large your project becomes, only the minimal necessary data are transferred to your computer, making projects quick to open, edit, and also save. So again, let's review the highlights here. PolyWorks is making the pre-production to production transition more efficient by helping you repurpose your pre-production projects and extend the life cycle of inspection projects. With security policies, templates can be customized to allow varying levels of read and write access based on defined user groups. And because of ongoing significant improvements to our piece capacity, Inspector with Data Loop can now begin accommodating many tens of thousands of pieces per project, efficiently transferring only the necessary data for the current local operations. This is data access made easy. You're collecting and consolidating hundreds of thousands of inspections. How can you organize, broadcast, and interpret your incoming inspection data and use it rapidly to respond as problems occur? Many of you are using third-party data management systems, but they generally offer only 2D reports, snapshots, or tabular data. You may see a trend, but it is difficult to trace back to real pieces. So when production problems occur, how does the manufacturing engineer get access to the necessary information to solve them? What would really help would be a way to access a well-organized summary of inspection results, with the capability to investigate those results more deeply as you wish, all the way down to the measured piece itself, and to allow the software to do much of the work so that you can focus on only the most pressing of problems, to do better root cause analysis and get actionable results.
Once again, say I'm the metrology team leader at my company and I'm working with Ben, who's the production engineer. He's in charge of all the production lines at our plant, and he's looking for a way to easily overview all metrology results. The following 3 examples will show you how I can help him. Remember our car door project we got from pre-production? We will see how we can set up a dashboard to monitor it. Then we will see how I can keep track, be alerted, and troubleshoot issues on our other active projects. And finally, we will take a step back and see what kind of trends we can find from all of the data that we have ever collected in the database. So let's begin. I was just about to finish this dashboard that I've created through the Data Loop web interface of the car door, and I want to look at the critical controls of the last 50 pieces. So let's go ahead and finish this off. I'll start by creating another widget. I'll create specifically an SPC style chart with a title of hinge 1 face deviations. I'll gather the information specifically from the inner car door project, and obviously I need to bring in information regarding this hinge 1 face deviation measurement. I'm only interested in the last 50 pieces, and let's add a monitoring rule which will alert us if we have any failed scenarios. Again, over the last 50 pieces, and let's turn the monitoring on and then save. That's how easy it is to create widgets on the dashboard. And lucky me, this one happens to have some fails in there. So let's jump into one of these pieces and let's drill down into this particular piece to see what's causing the issue. I can actually quite easily see where these measurements will be located due to this 3D interactive screen here. And it actually sees, or you can actually see where the measurement was taken. I can expand the SPC chart as well to view more stats and more details. And obviously it's clear that we can't accept these many pieces out of tolerance. We will have to figure out the issue and fix it. We are running the part on 3 lines, and Ben wants to know if it's affecting all the lines. Now, since properties have been entered for the pieces, I can filter by line by simply going into my filter list, enabling my lines, and I can then enable the line filter and choose to show maybe line 1 only. Apply. As that filters out, you can see there everything's fine with line 1. Let's have a look at line 2. Same again, no failing parts, which obviously means all my fails are currently in line 3. This is important information to share with Ben. He will be pleased to know that the issue is specific to line 3, whereas line 1 and 2 won't need to be stopped. And I can easily share this information by simply sending him an email using this share by email icon here. This will generate a link that allows him to open up this web interface to exactly how we are seeing it right now. All right, we have something to monitor our car door project now, so let's have a look at some of the other parts currently in production. We have a roof being manufactured, which with all critical controls, everything seems fine. Let's have a look at our hood. And right, okay, so we can see that it looks like this one is actually getting out of control, and now I have some controls that are failing. But with the SPC charts only, it's hard to know why. So let's drill down to one of the failing pieces again. And what I'll do is I'll display my control views, because we typically set up a color map control. So we'll have a look at fails only. And you can see here, the part was scanned so I can visualize a 3D color map in the data loop web interface. And it seems that this part has too much spring back in the middle here, and it's lifting in the center. So what I can probably do here in this situation is grab one of the metrologists to go and inspect the die. They can take a portable arm, a laptop, and go directly to the die. And because of the template of the inspection of the hood die is already in data loop, they will only need to search for the die number, download the template, and make a new piece. With Inspector Open, the metrologist can use the Open button to search for the project. And since he knows the part number, he can use it to search and filter for the relevant projects. He finds the inspection project of the part and also the inspection part of the die. And he looks inside the die project and finds a template to inspect with an arm. He can then download the template from Dataloop server to his computer. From Inspector, he can start a new piece. He will then follow the automated sequence, which will prompt him to scan the die. And once the inspection is finished, he notices that there is damage on the die, which prevents it from closing accordingly. He can upload the results to Inspector, to Dataloop, and add a meaningful note. And from within the interface, he will be able to, I will be able to search the new inspection, and this will allow me to review the results instantly with Ben and act accordingly. With that information, we would be able to plan and repair of the die. Now let's take a step back and look at the bigger picture. We have lots of inspections in the database, but what kind of information can we get from those? Let's look at let's look at this dashboard that I created. I created a dashboard called Metrology Overview. And looking at the different properties we're collecting from all these pieces, I found two interesting issues. First of all, we have this chart here, which shows us the approval status by production machines. Let me just remove some of these unnecessary fields. And you can see that it expands, and we can see that this particular machine here actually has a high ratio of failed parts. And this should be investigated. Now, this is something we couldn't see before, as the data was probably scattered across the entire company. The second graph shows, again, approval status, but this time by supplier. And it shows that the supplier, GDS, at the end here, again, has high ratio of failed pieces compared to its competitors. And this is something we might want to discuss with the supplier. Once again, I want to share this information with Ben. So even with dashboards, I can simply use the share by email button here, which will create a link for Ben to view my dashboard exactly as you're viewing it right now. On his side, he would even be able to add my dashboard to his list of dashboards by simply using this favorite button here. So all the graphs are possible because all the properties collected for each piece, but most importantly because all the inspection projects have been centralized in Dataloop.
So you've all just seen how Keith can use Dataloop to create a personalized dashboard summary of his projects. For real-time monitoring, he can use the SPC widget color feedback and let Dataloop look for patterns in the data and forms and from standard SPC rules. He can use Dataluup's powerful filtering and drill down capabilities to investigate his results so that he can see not only what, but why. He can then instantly share that information with any of his colleagues with the appropriate credentials. With Dataluup, Innovmetric are offering a summary view of all the metrology results, shareable with colleagues, off-site or working from home with web-based data access. Instead of piecemeal results, you can consolidate and organise all your valuable metrology data. Additionally, the capabilities of the web interface allow users to troubleshoot and pinpoint the root cause of problems and to distribute and share the status with others. So the highlights this time are: using the Dataluup web interface, you can build an environment that monitors and analyses measurement results in real time, and you can share those results instantaneously, working together to improve inspection projects collaboratively. Using powerful filtering tools, you can now uncover trends from multiple sites and devices, revealing the context of measurement variation so that you can initiate urgent investigation tasks easily. This is digital connectivity that boosts teamwork and efficiency. We've observed your work environments, and Innovmetric have worked hard to develop the most valuable tools to streamline your processes. You wanted to aggregate inspection results from all devices, including digital gauges, in a universal format. They have developed robust data management for hundreds of your devices. You also wanted to streamline and standardize your inspections pre-production to production. PolyWorks now allows you to customize and control inspection plans in templates, so you can now accumulate tens of thousands of pieces in a single project. You also wanted intelligent inspection problem solving. Dataluup offers feedback tools to alert you to developing trends, plus clever filtering for troubleshooting and sharing to make sure everyone can be on the same page. And once again, this is where we will pause for some questions. So if anyone has any questions from the first presentation as well. And again, you may have to minimize the chat, the video to see the full extent of the chat. So we'll just get those loaded up for you now.
Okay, so we've got a question from where we can get the gauge R&R spreadsheets from. I believe they're available from Innovmetric's technical support zone. These are kind of basic templates that they've created for people to download, so they should be available on there. So can you add values from an Excel file or text file into Dataluup? Yes, essentially within PolyWorks you can load with a macro, you can load in information from an Excel file, text file, CSV file, generate, for example, custom measurements. All that information within that project can then be uploaded to Dataluup so everyone else can see. Are all the subjects we have touched on so far included in the 2020 version? Yes, everything we've shown you today is in the 2020 version currently. I think we're currently up to Intimate Release IR5. And obviously stay in touch with any new Intimate releases coming out. More will be added as you would normally expect.
Is it worth noting that Dataluup's an extra?
Yeah, that's worth noting. Dataluup. So obviously, for the most part, we showed you obviously the metrology suite, but a lot of the things to do with Dataluup, the web interface, that is actually a separate module. But obviously, just get in touch with us if you want any more information regarding that, or if you want a separate demo for that. Can the measurements be linked to the machine tool operator and gauge? Is that if I'm reading you right, then you can create custom properties within your projects, and obviously what you can do then is make sure that the operators are filling in that information, so you can keep track of which machines you're using, who the operator is, with the gauge and so forth. Will Dataluup slow down the sequence, reduce speed of measuring, and as a result reducing the CMM time measuring? Again, if I'm reading you correctly, it shouldn't really affect your actual measurement time. If anything, in reality, it should really speed things up for you, since if it's a brand new project on the database and you don't actually have access to it, If there's already existing measurements in there, then obviously the beauty of data loop is it will download just the relevant information you need. So say, for example, there's 100 pieces in the project, you're not having to download all 100 pieces. Instead, you can just download the template and then start measuring, which will be a lot quicker. Can we add notifications on our spreadsheets? For example, generate a warning when a part is nearly out of tolerance. You can, spreadsheets being the Excel files, I don't believe so, no. You can obviously have your you can format it so it changes colors and stuff, but I don't know whether it will actually generate any warnings for you, if that makes sense. But if you're talking about the actual web interface with the charts and trends that you saw there, you can create alerts in there, which will then highlight and warn you of those. All good. Any other questions? Feel free to drop us an email. Again, hopefully you all know now. By now we have our support email address, so it's just support@3dscanners.co.uk. But yeah, I'll let Ben carry on.
Thank you for your questions. Just to finish off the second presentation. PolyWorks helps you analyse and solve production issues by providing 3 key benefits. Inspector is the universal platform that can connect to our process data from almost any device, while Dataloop optimally stores the inspection data produced, including projects, their revisions, and 3D measurement data in a centralised database. Inspector projects can be extended and repurposed from pre-production to all production devices thanks to templates. With Dataloop, all users can collaborate in the same project efficiently with minimal data transfer and efficient storage. Finally, using Dataloop, you benefit from powerful instantaneous sharing, filtering and feedback so you can review results on any platform and target problems with specific knowledge. And that brings us to an end of our second presentation and all presentations today. So we at 3D Scanners would like to thank you all again for attending our first PolyWorks conference live event, as well as your continued custom. Remember that we're always here for your support, to support your inspection and reverse engineering needs. Please, everyone in this current time, please stay safe, and we look forward to seeing you all at our next event. Thank you.